Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk.
Hey, Fred.
It's been a while since we've chatted, and we got a question I thought you might be able to dive in on, because I have a vague impression of I have a pretty clear picture of what you're going to say.
Gosh, Fred, after 6 years, you think you know.
You think I know.
Yes.
I might be surprised. Every now and then you do surprise me. So
okay.
So the gist of the story, the question, and I traded email a couple of times and tried to give him my point of view, but I figured I'd give you a shot at it too.
All right.
So he wrote and said, we recently launched a product, and we had done a full reliability plan. We did, risk assessment, FMEAs, we did testing, we did all this stuff. And we had a model that using test data and field in history of what we've done in the past and, stuff like that to say that, we're meeting our target, our objective. They had a reliability goal and they said, we think we're going to be good. And they're starting to get field failures back pretty early in their process. Yeah. And it's because the users are using it in ways they didn't expect, in places they didn't expect. There's a few manufacturing, variation of parts. There's a couple of design flaws. They're getting stuff back, and they had no indication of these failures during their testing. And so part of it, my first reaction was, well, you can't test in reliability. And two is if your testing doesn't look at infant mortality type stuff, like run a halt test, you're probably not going to find that stuff, unless you mimic how users are going to use it. And you got to understand how and where they're going to use it. And so we went back and forth on that. So I figured, they really was focusing on how come we did all this testing, we didn't find anything that we're finding in the field. What did we, it wasn't, what did we do wrong? He said, so what should we do? And I says, well, what would be your first, given just that, and it really was just a snippet and it was all, he didn't give me anything priority. I don't even know what market it is. But you're getting failures that surprise you in the field. What should you do first?
What should you do first?
Yeah.
Well, you would better have a good understanding of why those failures occurred. Yeah. In other words,
root cause analysis. First, understand them.
Exactly. Absolutely. That's the first thing. And if it's a really scattered, you've got to have a pattern there for three of the same kind of failure mechanism to say, first of all,
it just depends on what it is. If it's missing a part,
it depends on what it is. Right. Right. You can sometimes determine, if it's a lack of solder on a reflow, or it didn't. You can see that it didn't get hot enough to reflow properly.
Or it was solder. Just the wrong part was installed, and you go, wait a second, how often? Is this automated? And they put the wrong reel on, and I got 10,000 of these now.
And you and I both know that the going from design prototypes to the actual mass production, or pilots and mass production, a lot of changes can occur, and especially in like components that the buyer, the procurement
start looking for second sources.
Second sources and a little cheaper sources and things like that. But that and then I'd go back, of course, to their testing. I'd say, what did you do in the test? What kind of testing did you do? And you mentioned halt, but I would say in halt, you don't want to find most of the time. I would argue that infant mortality comes from, for the most part, manufacturing defects, either a wide distribution where some parts are very weak, or something to that effect. That you can design out by not being so dependent on that part, or having a narrow range that part has to, or having a wider range that the part can operate.
There's
a lot of design
Well, there's always arguments, and my opinion is it's always the designer's fault. So I was doing a halt once on a consumer product, and from the battery case, it was portable. So from the battery box, they ran a bare wire, a stiff wire down. And originally it was going to go straight down and solder into the circuit board. And for whatever reason, they changed the circuit board. And so it had to go over to the left, say about half an inch. So they put a bend in the wire and then put it into the board, and they hand soldered it in. It was a through hole and clipped, and bent over. So it was a pretty decent through hole solder joint. And when they put it together, but the bend was right on top of the conformal coating, not the conformal coating, just you look at a circuit board and it's green or blue, and it's not conformal coating. What's the top layer called? It covers the trace, the copper traces.
Mask.
Solder mask.
It's a solder mask, right?
Yeah. So it was right down on top of the solder mask, or really close to it. So we put it in halt, and it wore right through that solder mask. And of course, it found a circuit right under, or a trace right under it, which was the opposite polarity straight back to the battery, and shorted it out. Right. So the mechanical engineer that created this little wire, and here's the dimensions and the drawings and the study and the finite element and everything else he did to get this little fix put in here, blame manufacturing for not following his drawing. I was like, you gotta be kidding me.
Right.
You got it flat on if I follow your drawing, they'd have to make it really poorly before it wouldn't touch the top of the solder mask. And what do you think? The solder mask is insulating. It's going to keep your wire from rubbing through it. And so anyway, he blamed manufacturing. Manufacturing blamed the design. They went back and forth. We just fixed it.
Right.
That's all we did.
Right. And how did you fix it?
We put a piece of carpet tape underneath it, so it had to wear through a 1/4 inch of stuff. It also dampened it, so it didn't vibrate as much. But we just glued it down, basically.
Well, it's kind of a design. You've got to consider design for manufacturability and those kind of things. But again, you caught it in halt. So if this had been done early, you would have seen it, that kind of thing. And that, in fact, should sell them on halt once you found a problem that they did see in the field. They already know now that if we've done better testing and tested to the limits and found the absolute, fundamental limits of the technology of, what it could do, or weaknesses that might be evaluated as risks to the field, that's what you find. And
that was kind of my second point to this guy is, what should I do now? And I said, well, understand the failures and design them out, whether it's the design or the process, fix it. Right. And 2 is do halt. What else is going to fail that you don't know about? Because if testing it to feature, like it's supposed to, the green light turns on when I turn it on, okay, so there's no stress here. You turn it on and off 10 times. Is your switch a problem or a concern?
Right.
Is there,
right. But you also mentioned that they had applications that they didn't anticipate, or the user might have been using it in applications they didn't anticipate, which is kind of a failure of the, survey of potential users, or not understanding the market necessarily, or understanding where their parts are going. I'm not sure what it was, but that was a little bit of research failure in knowing how, of course, a new device, somebody says, we were looking for something like that to go down this, well. Yeah. Or we were looking for something like this to be put in a car or a vehicle.
Well, you could see engine. Well, you're joking about that, but you can imagine the GoPro, put a weight underneath it, drop it down in a well to do a visual inspection of it.
Sure. It's a tough little camera. I don't know that it could take 30,000 PSI, but
yeah, but it can go 20 feet down into the pool to look at,
Right. So, but it was built for that. I mean, it has a case. I had one. There could be one in the.
You didn't put it in the blender, did you?
No, it's probably sitting at the bottom of near an island in the British Virgin Islands.
Oh, so you don't need to put weights on it.
No, it may be there after the hurricane. I don't know. It could have been washed up on shore. Would be interesting if anybody ever sent it back to see if water ever seeped into the waterproof housing. But
Yeah.
I'm sure there's lots of cameras down at the bottom of those,
Oh yeah, I'm sure there are.
right below where all the yachts dock. You know, it's like they've dropped a few phones too.
Oh, I found a phone. I was getting ready to do a triathlon, and we're getting warmed up, and for swimming. The first segment is swimming, so we're getting just warmed up and it was in a harbor. They cleared out a lane for us to swim out and back, and we're three of us are kind of floating there and chatting, and somebody goes, "Oh, look, somebody dropped a phone," and it was right about the time the new smartphones were out, and he dove down. I don't know, it was probably 15 feet down. And picked it up and goes, "Hey, it still works."
Yeah, they're water resistant.
No. He was joking. It was.
Oh, it didn't. It's gone.
It had barnacles on it. It'd
been there for a while. Okay. No, it wouldn't work. But they do now. They are much more water resistant. And, I would quickly grab one and not worry about putting it in a bag of rice necessarily.
But one of the things that
there are limits, right?
So the one part is you shouldn't be surprised, and part of that is understanding the use environment, and that's part marketing, that's part quality, that's part design. Reliability is in the middle of all this, because if we don't get it right, we have failures.
But there is a fuzzy line.
There is a fuzzy line,
between what a customer may think he can do and what is really possible. For instance, if we were to try and lower that GoPro into a volcano.
Yeah. If it was wireless, it would send pictures back for a minute. Yeah.
It'll go for a minute maybe, and then it's gone. And you can't expect it. That's, way beyond anything that technology can do. I mean, let's look at this. We've sent a probe that's going through almost the corona of the sun now, which is millions of degrees, and they're amazing that they've been able to, they're able to use the shields and everything to have what the images are of little particles coming out of the corona and things. If you've seen it,
I heard about that project, but I thought, it's going to get close and just vaporize.
Right, and we've got the new telescope.
Oh, and they have big shields on it, so it stays close to zero.
Zero Kelvin. I mean, that is an amazing technology. One side keeps the hot side hot and the cold side cold.
But it also, I wish I had an ice chest that would do that.
That's right. And I'm sure they've had margin on the, I assume they froze everything to 0 Kelvin, as close as they could get on Earth
to make sure Kelvin. It worked. Well, yeah. I mean, but I was teaching a class in Houston at NASA for Houston, and they took me on a tour one day of their labs, basically. He said they can replicate all of the conditions of space except the low gravity. And so temperature, the radiation, sun, the vacuum, and there's a monstrous building. So they put the whole satellite, their whole payload in there. And if it's a vacuumous space, it's got infrared simulating the sun on one side, and they rotate it, but through shadows. And it's mind-boggling what they can do. And he goes, but we're working on that gravity thing.
All they have to do is put it on what they call the vomit comet, the plane that does weightlessness. All they have to do is put all that complex system on one of those planes, and there they got temporary weightlessness.
There you go. You see the 747 with the space shuttle strapped to the top, and inside is the payload with all this monitoring and stuff, and it going up and down, up and down. No, I don't think that's going to happen.
I don't think that's going to happen. But
no, that would be outside the use conditions for carrying the space shuttle back home. But part of it is that I've seen it in organizations. Well, marketing they told us what the customer's going to do. And then you design something that now the customers do something different with it, and it doesn't work.
Right.
That's not marketing's fault. That's you guys not thinking this through as a team. And marketing blames quality. Well, you're the voice of the customer, and they blame this, and I'm like, stop it. it's not working. Let's change the process. So that's the second thing, right? The third one is just because you did a bunch of testing doesn't mean it's going to work. Is you're testing, replicating the stresses that your customers are applying to your product. And so just because you think you know what the customer's doing, that's one mistake. The other one is if you really do know what customers are doing, but you only use industry standards that go from 0 to 100 and they don't, you go way outside all these limits all the time. Well, yeah.
That's why you shouldn't really be, that's why you should focus on the limits and pushing it to and finding what causes the limits and saying, can you make those any better with standard material? Can you increase those with standard materials and standard processes? That's kind of it. But
yeah, well, you know that there's this gray line in that whole argument is that, if I made it out of titanium, we could withstand this.
Right, but that's not a standard material. That's
no. But if I'm already using stainless steel, then I find a limit there. But the point is that if you're way above, but you have to understand how and where the cut product's used. If it's a stationary product on a desk someplace in an office and not pourable on anything else, just because they found a limit for one material that's, eons or ages or light years away from its use conditions, I got lots of margin. I don't need to change that one just because I found a limit. Even though it's a technological limit, I don't have to fix that.
No, but let me go back a little bit to what you were saying before about it's got to be, you stimulate the product the way it was in the field, or what the
types of stresses it's going to see. Yeah,
the types, right. But there are cases like my first, project with a power supply company that set in semiconductor manufacturing equipment. Okay, in its life, it has, except for shipping, it receives very little vibration. But vibration does if there's a weak solder joint or cracked solder joint, which may degrade and finally become an open circuit with expansion and contraction through thermal expansion and contraction. Right. You can stimulate that and accelerate it much faster through.
Well, yeah, no, I agree. I agree, but you need to focus on.
You may not see that, right? You may not. You say, well, it'll never see that stress in its life.
No. I'm not saying that. There's plenty of ways to go about, accelerating failure mechanisms, but part of that comes from knowing what you're looking for.
Exactly.
Right? But the part of the question is that we're being surprised by what we're getting back, and so they were quickly labeling them customer abuse, which is another problem that.
Well, it is, and like I say, the GoPro down a volcano would be customer abuse. So,
Well, I bet if you get 30 of those, after 1 week, you get 30 of those failures. Oh, it didn't survive the volcano plunge. We were on, we're at Maui, or where's the big island, and we were tracking this volcano flow, and it didn't survive. We chipped it out of the hardened lava, and it was gone. And the wire, the power supply was fine, but
exactly.
But if you get a whole bunch of those, right? If you get a whole pile of those, somebody better say, hey, we might need to make these waterproof or volcano proof or whatever. There might be a market for that.
They're right. And we can charge a lot more. And that's another thing. Maybe the sales department or the people that were selling the product, weren't feeding back where this customer wanted to, he was anxious to sell the product. So he didn't necessarily tell ask the engineers, will it survive this, or this is the way the application the person wants to. Sometimes they do. They have an application.
They had a great ad where they, had this volcano and they had a fishing line and they dropped it in there and got pictures of the inside of it. It was just in the ad. I mean, I don't know why it set expectations that it would work.
I think it's funny now that Apple is doing in their ads showing child-proof phones, where the kid walks around, drops it, beats it on the,
uses
ground.
A hammer, gums it.
And it's showing that the manufacturers are actually making more robust phones
Oh yeah.
that wouldn't withstand what they show on the Apple ad, and or other smartphone. I don't know that anybody else's. Really, I haven't seen any ads. I guess I don't know, showing how the ruggedness of their phones and how much more strong they are.
Yeah.
So but it's always the case where a lot of times there is an application that has special stresses in it, or different stresses, or extreme stresses, and a consumer product then needs to be that would have, like, it's like a consumer blender versus an
Industrial one.
Yeah, I know.
Yeah.
Yeah, like the one you use in a shake shop, ice cream shop, or something like
Yeah.
that. That you wouldn't buy just a typical blender, probably, or you could put typical
No,
blender.
it's the same. You don't go down to Sears. Do they still exist? And buy a dozen washing machines and put them in your laundromat. Those
No,
laundromat ones
right.
are different,
Specially built, right?
to run all the time and all that other stuff.
Right.
So, but anyway, back to this guy's question: is what do you do now? Is one, understand and fix the problems. Two, take a close look at what you're doing in your testing and prediction and your modeling, that you missed these signals for these kinds of failures, because you've got great information now. And I'd say three is you need to understand your customers better.
Right.
Understand what they're doing. And it might be a market opportunity, but it also might be that your process of listening to what your customers want from a product and how they're going to use it is broken. You need to fix that. And all of those are reliability things that we could lead.
But you need to find those things out before you get it to the customer. And so one of the things I'd add to that is, initially in the first pilot runs, you probably need to do a highly accelerated stress screen. In other words, stress based on the limits of the product, okay, on what you've already, if you've done a halt and tested the limits, then you need to develop a house and apply that to the first 200 or maybe 1,000 units, to at least a sample of them, to see what your initial learning curve in manufacturing is, because that certainly attributes a lot to unreliability. So that would be my addition.
And then, depending on what you learn from the failure analysis and the root cause analysis type stuff, then you'll have a pretty good list of what to go work on.
Right.
Yeah. Never a dull moment.
That should guide you completely on what to do until another customer uses it in a different application.
That's right. Like a volcano.
It's a dynamic target sometimes.
It is. So if you got a question for us, or have a query or something like that, or a comment back on this particular question, let us know. Head over to accendoreliability.com/go/SOR. And you can find a widget there to record us a message, or you could leave a written message. You can find Kirk and I on LinkedIn or on our About pages through Accendo. Lots of ways you can get in touch with us. And as you can tell, we really enjoy these questions and actually try to help. And then we make fun of it when we talk about it in the show a little bit, but not always. But
we wish we could know more.
Yeah.
we wish we could know details of all these issues, but NDAs will keep us away from ever really discussing a lot of it.
Well, we can convey a lot of information real quick, right. And if it's a quick question, I have no problem answering your question directly, and get on the phone and we'll have work it out.
Right.
But I'm not going to design your product for you. I charge you for that.
Yeah.
So anyway,
that's right.
Well, thanks, Kirk, for chiming in on this one. It's I knew you'd
Fred.
I knew you were going to talk about halt and test the limits and all that stuff. But that's a good answer. It's a good answer.
It's a deep pool of opinions in reliability.
Okay. Right.
We'll talk to you again soon, hopefully.
Yeah. Cheers, Kirk. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.